In this video, we will be discussing Einstein photoelectric effect. Einstein explained the photoelectric effect on basis of photons concept of light, which is also known as Einstein's quantum theory for photoelectric effect. So before we discuss further, let me draw one diagram. This is cathode plate from which electrons will be emitted. This is incident light. Let it be C. This is anode plate, which will be collecting the electrons. So we can say this is photosensitive plate. And this one is collector anode. So photoelectric effect is the phenomena of emission of electrons from the surface of a metal when light of suitable high frequency, that is having frequency equal to or greater than the threshold frequency of the metal, is allowed to fall on the metal surface. So in this case, this is our light radiation that is falling on the metal, plate C. So this is the source of light. Now the frequency of this source of light should be having a frequency which is equal to or greater than the threshold frequency of plate C. Now once this light is irradiated on plate C, electrons will start moving from cathode C to this collector plate anode. Anode means this is kept at a positive potential so that the electrons are getting attracted from cathode to anode. Now this can be, and this whole setup is enclosed in a glass tube. So we can draw like this. Here I will be using commutator. And the electrons which will be coming, since they will be moving, so we will be having current which is known as photoelectric current, and this current will be measured with the help of an ammeter. I have kept a voltmeter here. This is positive, negative. Now what happens is, initially the electrons will be moving from the cathode toward C towards anode A, only if anode A is having a positive potential. If it is at a zero potential, there will be no movement of electrons because they will not be getting attracted from C to A. So more the potential I am giving to plate A, more there will be the electrons that will be coming from C to A. Now, if I want to stop this movement of electrons from C to A, I will have to give a negative potential to plate A so that I'm not getting electrons from C. So we discussed already, when the electrons are moving, we are having photo electrons and photoelectric current. So that is being measured by this microammeter. When it is negative potential, when the A is at negative potential, there will be no current in this ammeter. Now, as per Einstein photoelectric equation, this energy E, which is equal to H multiplied by the frequency, is divided into work function of the metal plus kinetic energy of the electrons. This work function is equal to H multiplied by the threshold frequency. So this equation, Einstein photoelectric equation, can be modified as E is equal to H nu is equal to H nu naught plus kinetic energy of electrons. So from this equation, we can calculate the value of Planck's constant H. So this is the basic video where we are explaining what is Einstein photoelectric effect. When a light of suitable frequency having frequency equal to or greater than the threshold frequency of the metal surface on which it is falling, then electrons will be released from that cathode or that metal. And if we are giving a positive potential for these electrons, they will be attracted towards A and we will be having a photoelectric current. So that's all.